Alright, in this test review I am just going to go through a bunch of different problems that you will see. Not exactly the same problem that you will see on the test, but very similar. Some of them will be more similar than others, but if you watch this and can do everything that I go through here, then you will be able to do work every problem you see on the Unit 1 test. So, without further ado, let's get to it. So first, you're going to be asked, can you find the GCF? So find the greatest common factor, and say I give you these two terms, 36 x to the 4th, y, z to the 7th, and 20 x squared, z to the 5th. Hopefully by now this is pretty basic review for you, but alright, greatest common factor. Well, what do they have in common? Let's look at the variables. Are really the easiest part to pick out. You can see that they both have x squared. Let me bust out my highlighter here, right? They've got x squared. Well, this one has x to the 4th, but of course that means it has at least x squared. We have to go with the smaller of the two. Okay, and they both have at least 5 z's. Right? The second one has 5 z's. The second one has 5 z's. The first one has 7 z's. So we know we've got an x squared, and we know we've got a z to the 5th that we can pull out. Now notice we cannot pull out a y because the first term does have a y, but the second term does not. And now let's just look at our constants. We've got 36 and 20. Well, what goes into both 36 and 20? 4 does. So the largest term I could factor out of both of those is 4x squared z to the 5th. And that's all you're being asked for there. Find the GCF. Moving on. Factor by grouping. If I give you 3mn plus 12n cubed minus m cubed minus 4m squared n squared. Alright, now yes, we've got two different variables here, but that doesn't mean we have to lose our brain and forget how to factor by grouping. Remember, if I'm factoring by grouping, I'm considering it like this. I'm looking at these first two, and then I'm looking at the second two. Now remember, this minus sign, even though I'm going to do this, I'm going to draw these parentheses here, but that really means there's a plus sign in between there. I don't want you to lose the fact that those are being added, not multiplied. Okay, so I'm looking at this first pair of two terms, and what do I see that I can factor out? Well, there's a 3 and a 12. Those are both divisible by 3. There's also an n in both of them. Now, I can't factor out more than one n because there's only one n in the first term. So I can pull out a 3n. And what does that leave me with? It leaves me with m plus 4n squared. We took one of those 3 n's and factored it out. That leaves two of them. Okay? That's the first pair. Now let's look at the second pair. Now keep in mind, when we're factoring by grouping, we want the sets of parentheses, we want the stuff that is in here to be the same. So we want to factor something out of this second pair so that we'd be left with m plus 4n squared. So that's kind of our help to think, well, how do we do that? You'll notice that there is an m to the 3rd here, and there's an m squared here. So that means I can pull out an m squared, but if we're paying attention, we should see that I need it to be a negative. I need to pull out a minus m squared, so that my signs will be the same as in the first set of parentheses. So when I pull out that minus m squared, I'm left with positive m plus 4n squared. And now to complete the factor by grouping, since these two sets of parentheses are the same, right, I can factor that out front. So I pull out my m plus 4n squared, and what does that leave me with? It leaves me with 3n minus m squared. Forgive my terrible handwriting there. 3n minus m squared. And that's factor by grouping. Alright, let's give ourselves some space here. And we're now going to factor just a regular trinomial. So let's say I gave you 6b cubed minus 21b squared minus 12b. And I want to factor this. Well, of course, you remember the first step is to pull out the greatest common factor. And I see 6, 21, and 12. Those are all divisible by 3. I also see that every term has a b on it. So I am going to factor out, before I do anything else, let me go sideways with this. I'm going to factor out a 3b. What does that leave me with? It leaves me with 2b squared minus 7b minus 4. Now at this point, there's multiple ways to go about factoring this trinomial. You can do it by the trial and error method, but I'm going to use what's called the AC method, which is going to turn this into a factor by grouping situation. All right, well, we know we've got our 3b out front. Now what I want to do is I want to take this middle term here, I want to take this minus 7b, and I want to rewrite it as two terms, still adding to negative 7b, but how do I know what two terms to split it into? Well, I multiply the a and the c. What I mean by that is, remember, a is the number in front of the squared term, the coefficient of the squared term, and c is the constant. So in this case, a is 2, this is a, and c is negative 4. Well, a times c then, a times c is negative 8. 2 times negative 4. Well, that's pretty easy. I can split negative 7 into, so what I want to do is I want to split it into two terms that multiply to make negative 8, but when I add them I still get negative 7. So what I'm going to do is 2b squared. Now here comes the middle term. I'm going to split it up. I'm going to split it into minus 8b plus 1b, or just plus b, and then the minus 4 is still there. Now, see how what I did there? Negative 8 and positive 1, you multiply them, you get negative 8, which is what we wanted, because a times c was negative 8. But if I add them, I still get negative 7b, so I did not change the value. It's just like taking the number 5 and rewriting it as 2 plus 3. 2 plus 3 is still equal to 5. Right? But the reason I did that is that now I can do a factor by grouping here. So now what I have is, even inside of these parentheses, I'm going to use a different color to make it stand out. What I've got is, I've got this pair here I'm going to group, and then I've got this pair here I'm going to group. So that's what we've got going on here. So I have 3b, don't forget about the 3b hanging on there. I'm going to change these outer parentheses into brackets so that I clarify myself here. Well, in this first pair of terms, 2b squared and negative 8b, I can pull out 2b. To be or not to be? That is the question. And this leaves me with b minus 4. And looky here, b minus 4 is already what I have in the other pair. So I'm just going to say plus 1 times b minus 4, because I can always factor out a 1. So now my final answer is 3b times b minus 4, which was my shared factor, times, when I factor that out, what am I left with? I'm left with this 2b and this 1. 2b plus 1. Ta-da! And that's that. That one was fairly involved. Now you've got like 4 of these on your test, and they're not all as involved as that one. In fact, maybe none of them are. I don't know. Maybe only one involved. One more example, just real quick. X squared plus 11x plus minus 20. Sorry. Now remember, if you've just got a trinomial where the coefficient of the x squared term is 1, which this one is, it's just a 1, right? Then we can just use our basic method for factoring here. Pretty straightforward. Well, what are my factors of negative 20? We've got, now of course everything can be positive or negative, right? So we've got 1 and 10. You've got 1 and 10. How about 1 and 20? Huh? 1 times 20? Yeah. 2 and 10, 4 and 5. And we're looking for a pair of those that we could add or subtract, since remember, one's going to be positive, one's going to be negative, since we have a negative 20. So we're subtracting them, and we want to get the middle term. We want to get 11x. Well, you can look pretty quickly and figure out that ain't going to happen. That is not possible. So this polynomial is prime. Can't factor it. Remember, if it can't be factored, it's prime. All right, moving on, moving on. How about a binomial? Negative 121 plus y squared. Now don't get thrown off by the way I've written this. Remember, this is the exact same thing as y squared. Now, for some reason I've lost part of my y. There we go. Minus 121. I can rearrange the terms, right? As long as you keep the sign connected to the right term, you can rewrite them in any order. So don't get thrown off if this negative thing comes first. You just flip it around and think about it this way. Hopefully you remember, this is a difference of two squares. So I can rewrite this as y plus, what's the square root of 121? Why are my y's not cooperating? I don't know. The square root of 121 is, of course, 11. And then we have y minus 11. Remember, it's just the variable plus the square root of the second number minus the square root of the second number. And there's my factored form. Alright, now the next step is to take these polynomials that we've been factoring and to solve an equation. So for instance, negative 12x squared plus 48 equals 0. So now we've added an equal sign on the end. And so now instead of just factoring it, you're asked, solve this. Well, okay, same process though, it's just that we have one step on the end. So I'm going to start by factoring out the greatest common factor, which in this case is a negative 12. So if I factor out a negative 12, I'm left with x squared minus 4 in parentheses, and that equals 0. Now, of course, x squared minus 4 can be factored. So we have negative 12 times x plus 2 times x minus 2 equals 0. All right, again, difference of two squares. So now remember, at this point, I've got a bunch of things being multiplied on the left side. This, all being multiplied to equal 0. The zero product principle tells me that one of those things must be equal to 0. Of course, it can't be negative 12. We could just divide the whole thing by negative 12 and that would disappear, so we can ignore that. So what we do is we take each factor and set it equal to 0 individually. So we take x plus 2, set it equal to 0, and we're going to take x minus 2 and set it equal to 0. So it's pretty quick to solve. Here we would subtract 2 and get x equals negative 2. Over here we're going to add 2 and get x equals positive 2. So my answers would be, now be careful about on MyMathLab when you're entering these answers. I believe it says enter the answers separated by a comma. So you would say, you know, it doesn't matter which one you list first, 2 or negative 2, but you list one, then you put a comma, and then you list the other. Just read carefully about what format they want you to enter the answer into, and you can save yourself a lot of grief. Let's do another example like that. I'll just do it over here beside it in a different color. What do we got? We got w, I've still got an eraser for some reason, w cubed plus 10w squared plus 24w equals 0. Now, what can I factor out? Notice every term has a w, so I'm going to start by pulling out that w. So that's w times w squared plus 10w plus 24 equals 0. Now at this point, factor that trinomial on the inside. That should be pretty easy for you to factor. Don't forget about this w that's out front. So I'm going to go bang, 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 get my two sets of parentheses. Where did that random line show up from? I do not know. And this still equals 0. Now the nice thing about this one is there's nothing but plus signs. So I've got a plus, I've got a plus. You know you've got a w here and a w here. And then you're thinking, well, what numbers multiply to make 24 but add to 10? And that would be 6 and 4. Okay, and you can FOIL that back out and check. Now, at this point, we have three factors. We've got a w plus 6, and a w plus 4. Those all have to be set equal to 0. Well, obviously, w equals 0 is just one of my answers right there. And then if I take w plus 6 and set it equal to 0, I would just subtract 6 from both sides, and I'd have w equals negative 6. Another one of my answers. And then same process for w plus 4. W plus 4 equals 0. Subtract 4, and you get w equals negative 4. So when you go to enter this in the answer blank, you'll have w equals, and then They give you this box and say enter your answer with comma between. Again, the order doesn't matter. So just 0, comma, -6, comma, -4. They don't care what order you enter your answers in. And there's my answers. If this is all new to you and you feel like I'm going too fast, then you're in trouble, because this shouldn't be the first time you've seen this. This is just a review. Alright, moving on. You will be asked to choose a graph from an equation. So now I'm going to take these equations we've been dealing with and I'm going to replace that 0 with a y. Let's think about, for example, if I gave you x minus 1 times x plus 2. Let's see if I can, real quick, see if I can find... Oh, that's not what I wanted. There we go. I want to copy you. Alright, now I'm getting there. Okay, and now I want to paste. Alright. Let's see if I can... No, I'm not trying to draw. Oh well, that's fine. I'll leave it where it is. Alright. X minus 1 times x plus 2. Now keep in mind what we have been doing. We've been working one that looks like this. You've had x minus 1 if it was like this, if you factored it. And you said, well, this is equal to 0. That's what we just got done. We just got done solving equations that looked like that. Well, now see, basically all we've done is we've taken a y and replaced that 0 with it. So if you think, well, what if the y were equal to 0? Where is that? Well, where's y equal to 0? That's right here on the x-axis. That's the line where y equals 0. So essentially, the way you can figure out what this graph looks like is just say, well, okay, where does it cross the y-axis? Well, this one is going to cross the y-axis at x equals 1 and x equals -2. How did I figure that out? I figured that out by taking each factor and setting it equal to 0. So you should know that you've got a point right here and right here. And then the rest of it should be fairly straightforward. It's just a parabola opening up. So you don't have to be very precise on this. This will be multiple choice. So once you figure out the correct intercepts there on the x-axis, then you should not have a problem graphing this. Keep in mind also, if you want one more point, you can plug in 0 for x, and that will give you the y-intercept. So if you did that, if you did 0 for x, you'd have y equals 0 minus 1 times 0 plus 2, which of course is just -1 times 2, or -2. So I'm going to have to draw a better picture than this, because the y-intercept is supposed to be right there. So let me do a little better. I can do better. There you go. But again, you're not going to be drawing it, you're just going to be choosing the correct graph. So you want to use that factored form to find the x-intercepts, and you can also find the y-intercepts pretty easily. Okay. Now, I just talked about this, but here's a different problem. Say you're given this equation. This time it's not in factored form, and you are asked to find the x-intercepts. What are the x-intercepts? Well, again, just factor it. It's pretty quick to factor. You've got two pairs of parentheses here, just factoring a regular old trinomial, x and x. Now notice the last term, the 6, is negative, so that tells you you've got a plus and a minus. You have to have a positive and a negative if the last term is negative. And now you're thinking, well, what multiplies to make 6? You've only got two choices. It's either 1 and 6 or 2 and 3. Those are my options. But one of them would subtract to make 5, to make that middle term. So I'm going to have to use the 1 and the 6. And since the 5 is positive, I want the bigger number to be positive. So I'd say plus 6 minus 1. And now if I want to know where are the x-intercepts, then all I'm going to do is I'm going to replace y with 0. So essentially I'm going to have the exact same kind of problem we've had before. I have x plus 6 times x minus 1 equals 0. Now, take each pair, set it equal to 0, right? Take x plus 6, set it equal to 0. Take x minus 1 and set it equal to 0. And again, you're going to get x equals negative 6 and x equals positive 1. Now let me caution you here. People are going to make this mistake who don't watch this video. If you don't read carefully about how MyMathLab asks you to enter the answer here, you're probably just going to enter it like this, negative 6 comma 1. Well, in MyMathLab for this problem, they ask you to give ordered pair answers. So each of these points is an ordered pair. You need to write your answers like this. Negative 6, 0, and then a comma between, that's supposed to be a comma, and then 1, 0. That's how MyMathLab wants you to enter it, as ordered pairs. Remember that if it's an x-intercept, that means the y value is 0. That's how we figured out what it was, by replacing y with 0. So, just pay attention to that. Alright, moving right along. Let's see, let's do a domain problem. If I give you f of x equals x plus 12 over x squared plus 4x plus 3. Okay. Well, you want to know what the domain is. Well, what that means is you want to know what can x be. What can x be and what can it not be? We start with the assumption that x can be all real numbers, and then we start eliminating possibilities from there. We do not care about the top of the fraction, x plus 12. That doesn't affect the domain at all. You could plug any x value in there and you'll get a value back in return. But think about the issue here. The issue is in the bottom. We can never have a 0 in the denominator. So what we need to do is we need to figure out what values of x would make this denominator equal to 0, because those are the numbers that cannot be in the domain. So let's do that. How do we do that? Well, we factor the denominator. So what we have is x plus 12 over, now I gave you a pretty simple one to factor here. The last number is 3. It's only one choice. It's got to be 3 and 1. So we have x plus 3 times x plus 1. So now you're thinking, what values of x would make that denominator equal 0? Well, x equals negative 3 would, because if you plugged negative 3 in right there, that first factor would be 0. And x equals negative 1 would also, because it would make the second factor 0. So what we're saying then is the domain of this function is all real numbers except these two, except negative 3 and negative 1. Now, I believe you're going to have to enter this as using interval notation in MyMathLab. So as an interval, how would we say this? Well, we would say negative infinity, comma, negative 3, saying x can be anything in that range, and then you've got this u for union symbol, and then you go from negative 3 to negative 1. Now keep in mind I'm using parentheses here, which means the points are not included. So this is saying, so far what this is saying is everything from negative infinity up to negative 1, not including negative 3, because we skipped over negative 3. And then we're going to union again and go from negative 1 to positive infinity. This is a way to show, hey, x can be everything except for negative 3 and negative 1. This is how you would do it in interval notation. And just, again, read the directions carefully for exactly how they want you to enter your answer. Alright, now let's do some simplifying. Let's see what else we've got here. We've got simplify 12z squared minus 27 over 12z plus 18. Okay, so both top and bottom can be factored. Let's do that. On top, all I can do is pull out a 3. Well, if I pull out a 3, that leaves me with 4z squared minus 9. And on the bottom, what can I do? I can factor out a 6. And that's going to leave me with 2z plus 3. Now, you can reduce that 3 over 6, and we're going to get to that. But what you should also notice here is you're not done factoring. This 4z squared minus 9 is actually a difference of two squares. That factors. So let's go ahead and reduce the 3 and the 6. The 3 would become a 1, the 6 would become a 2. So I'm just not going to write the 1. So let's factor 4z squared minus 9. Well, that is 2z plus 3 times 2z minus 3. All of that over 2 times 2z plus 3. And now that you've factored the top, you see, well, looky here, we've got a common factor that cancels out. So my final answer here is 2z minus 3 over 2. And of course, my math lab will not give you any credit if you only get part of the way there. You have to simplify it all the way down to this point to get credit for this problem. All right, let's look at another one. Now this one involves some multiplication. 6x plus 6 over 5 times 10 over 40. No, all right, 42x plus 42. All right, now keep in mind when you're multiplying, you can cross cancel, you can cancel straight up and down. Anything that's on top can cancel with anything that's on the bottom. So before I do anything, of course I'm going to factor some. But what I see is, and let me come in here with a different color. Really? 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 Apparently not. I see that 5 being a 1 and that 10 being a 2. Those two can reduce right away. And then of course I also see that I can factor the top left and the bottom right. So I'm going to pull out a 6, and that's going to leave me with x plus 1. And we know that this is over 1 times, now we've got a 2 on top because we've already reduced the 5 and the 10. And then if I pull out 42, I'm also left with x plus 1. So at this point I see, well, x plus 1s can cancel. X plus 1s can cancel. And then you also hopefully see, and let me go to another different color because I like that, a 6 and a 42. Or you could reduce the 2 over 42. Either way, you're still going to have to reduce again if you do it that way. But 6 goes into itself once, 6 goes into 42 7 times. So after all of that, my answer is 2/7. All of the x's canceled. Everything reduces down to 2/7. Won't always turn out that pretty, but that one did. Not all nice and neat. Now keep in mind if you have a division problem, I'm going to make this one fairly involved. X squared minus 1 over 4x plus 12 divided by x squared plus 2x plus 1 over 5x plus 15. If you have a division problem, remember, the first thing you're going to do is you're going to flip that second fraction and change it to a multiplication problem. Or, you know, as Missy Elliott would say, you're going to put your thing down, flip it, and reverse it. That's what she would say. She didn't know she was writing a song about math, but she totally was. So that's what I'm going to do. First off is I'm going to rewrite this. Now let's go ahead and factor while we rewrite it. X squared minus 1, well, that can be rewritten as x plus 1 times x minus 1. It's a difference of two squares. Over 4x plus 12. Well, I can factor out a 4, and that leaves me with x plus 3. And then times, now I'm flipping the second fraction, so the 5x plus 15 is coming up to the top, except I'm going to pull out a 5, and that's going to leave me with x plus 3. And then the x squared plus 2x plus 1 comes down to the bottom, and that is just x plus 1 times x plus 1. That's a pretty standard trinomial to factor there. So now, let's start canceling stuff out. What can we lose? We can lose a couple of x plus 3's. We've got an x plus 1 and an x plus 1, and it looks like that is all we can cancel out. So then our final answer for this problem becomes, what do we have on top? We've got a 5 times x minus 1 over 4 times x plus 1. And you want to just leave it in that factored form for your final answer. Alright. Okay. Let me get a little more space. We're getting there, people. We're getting there. What's next? How about some addition? How about I give you 7 over q plus 10. Now that looks goofy, right? But think I need a common denominator if I'm going to add fractions. Well, my common denominator is gonna have to be q, because that's the only thing in the denominator of the left fraction. So how am I going to get this 10 to have a q in the bottom? Well, it's actually fairly simple. We're just going to come in here and think of 10 as being 10 over 1, right? And what we're just going to do is we're going to multiply it by q over q. So this gives me 7 over q plus 10q over q. So my final answer is 7 plus 10q over q. No, I cannot simplify that any further. That's my answer. I'm done. And if you write it as 10q plus 7, that's the same thing. The order on top does not matter. All right, how about this one? 11 over r minus 3 plus 14 over 4r minus 12. Well, it's going to be, every now and then my eraser just randomly decides to poke its head out. Okay, now in order to see what the common denominator is here, you really need to factor this right one. 4r minus 12, I'll just do it right underneath. We'll factor out the 4, and that leaves you with r minus 3. So let's ignore that now. Well, so notice, what's the difference between the two fractions? 4 times r minus 3 and r minus 3. So the only difference is that the first fraction is missing that 4. Well, that's pretty easy to rectify. We're just going to come in here and multiply by 4 on top and 4 on bottom. That's supposed to be a 4. Now keep in mind this r minus 3 needs to be in parentheses. Think about it that way. So now what does that give me? Well, that gives me 4 times 11 is 44 over, you don't need to multiply out the 4, you can just leave it as 4 times r minus 3 plus 14 over 4 times r minus 3. Whoa, okay, whoa, crazy pen. And now we have a common denominator. We can add. So this 44 plus 14, that is 58 over 4 times r minus 3. And here, be careful, if you're not done, if you don't reduce, 4 and 58, those can reduce. They're both divisible by 2. So if you divide them both by 2, you have 29 over 2 times r minus 3. Don't forget to reduce there on that last step. Okie dokie. Flying right through this here. What do I have? Oh, how about a complex fraction? Let's do a couple of complex fractions because you're going to see a couple of these on your test. So you're going to see, we'll do an easy one first. 7 over 10x. All of that over 21 over 5x. Ah, stupid eraser. 21. Okay. Now remember, a complex fraction is just another way to write a division problem. So forget that it's a complex fraction when it's written like this, and think of it like this. This is 7 over 10x divided by 21 over 5x. And you know, since it's division with fractions, you're just going to flip that second fraction. Keep change flip. Change the sign to multiplication. Flip the second fraction. And now we've got a whole lot of reducing we can do. 5x and 10x, well, those two are going to completely reduce to 1 and 2. And 7 and 21, that's going to be a 1 and a 3. So altogether my answer is 1/6. That one was pretty simple. They won't all be that simple. But let's look at an example of a complex fraction that is a little bit more involved. Now this does not have any variables in it, but it looks goofy. It usually throws people off because it looks funny. Here's how I would advise you to work this. You could think of it as a couple of mixed numbers and do it that way and get rid of your fractions and you'd have a complex fraction that looks like the one above this. But I think the easiest thing to do here is just to get rid of the denominators altogether. So in this case, when I say get rid of the denominators, I mean, well, you've got a 5 here and a 5 here. So if we multiply everything by 5, we'll get rid of the fractions. So let's do that. If I multiply everything by 5, now keep in mind, what I'm doing is I'm multiplying, really? Still a highlighter. That's interesting. That's fine, I'll go with it. Now let me change. What I'm doing is I'm multiplying the top by 5 and the bottom by 5. So you can't forget to multiply the whole numbers also. So I'm distributing. Right? I'm really distributing. So 6 times 5 is 30. plus 3/5 times 5 is just 3. The 5's cancel out. 5 times 5 is 25, plus, again with the crazy pen action, 25 plus 2/5 times 5 is 2. Really? Really? The pen's going wonky on me. So now we've got 33 over 27. That cannot be, oh, I lied. I almost lied. I was about to say that cannot be reduced. Oh, bad advice. Oh, man, I guess it must be getting late in this because I'm losing my brain. They're both divisible by 3. Hello, hello. 33 divided by 3 is 11. 27 divided by 3 is 9. If you put 33 over 27, you'd get it completely wrong, and that would be very sad to have done all that work and get it completely wrong just because you didn't reduce. 11 over 9. Of course, if that does happen, I'll go back in and review tests and give some partial credit where I can, depending on what your answer was. Okay. Believe it or not, we're getting kind of close to being done. I think I've got 3 more problems here to work through, and then you will be ready for that test. As ready as you're going to be. Solve this equation. 2x over 3 plus x minus 5 over 6 equals 5/6. Okay, if you have an equation like this with a bunch of fractions, I say, this is what I think is the easiest way to work this. Instead of trying to get a common denominator, just get rid of the fractions altogether. So what's my least common denominator here? Well, I've got a 3, I've got a 6, and a 6. So 6 is my least common denominator. So if I multiply everything by 6, then I'm going to get rid of all my fractions. So that's what I'm going to do. I'm just going to come through, I'm going to multiply here by 6, I'm going to multiply here by 6, I'm going to multiply here by 6. Got to do it to everything or else I change the problem. Well, on these 2 fractions here, those 6's are just going to cancel out. But on the first fraction on the left side, 6 over 3 is going to reduce. The 6 can be thought of as a 2, and then makes that 3 become a 1. Sorry, excuse me. So now, multiplying, I've got 2 times 2x, which is 4x, plus the 6 is canceled out, and all I have here is x minus 5, equals 5, because the 6 is canceled out on the right. Now it's a pretty simple problem. So I've got 5x minus 5, just combining my like terms there. Then I would add 5 to both sides, and now I have 5x equals 10. Divide by 5, and you get x equals 2. And you can always plug it back in and check to see that it makes sense, and it does. If you plug 2 back into this original equation, you'll get the right answer. You'll get the same thing. All right. Let's do another example. Let me just split screen it here. Use a different color. You know how I like using different colors. All right. 3t over t plus 3 minus 2 equals 7 over t plus 3. Okay, now this one's a little different because there's a variable in the denominator. But still, if you think about what's my common denominator, well, this 2 can be written as 2 over 1. Any whole number can be put over 1. So the common denominator is still going to be t plus 3. Any of these denominators could be t plus 3. 2 of them already are. So that's what we're going to do. We're going to multiply through by t plus 3. So I'm going to multiply by t plus 3 here. I'm going to multiply by t plus 3 here. And I'm going to multiply by t plus 3 here. Now, of course, that and that are going to cancel. That and that are going to cancel. So I'm going to have 3t minus. Now, notice when I multiply t plus 3 by the 2, what I really need to do is distribute that 2. So let me just write it out first so that everyone sees what's going on. I'm really doing this. And that equals 7. So now distribute that negative 2, and I've got 3t minus 2t minus 6 equals 7. So how convenient, 3t minus 2t? Well, that's just 1t minus 6 equals 7. So add 6, and I get t equals 13. Now, let me caution you here. This one didn't work out this way, but be very careful. When you work problems like this, you must plug your answer back into the original to see if it actually works, because For instance, what if I had gotten, now this isn't the answer, but it could have been, what if I had gotten t, and write it in a different color so it stands out. What if t equals -3 was the answer I came up with? Well, if you come back up here and plug in t equals -3, you're going to get a 0 on the bottom of that fraction. You can't have a 0 in the denominator. So that would actually mean you have no solution. So make sure after you solve this that you check your answer in the original equation. You must plug it back in, because it may give you a number that works out mathematically based on the fact that you got rid of the denominators, but if you plug it back in, it might give you an undefined fraction. So you can't have that. Just make sure you check it, and then you'll be safe. Alright, last one, and this is really easy. You've got similar triangles. Pretend these look similar, please. I'm going to attempt to make them look similar. Well, they don't look very similar, but let's say this is 2.2. This is not going to be drawn to scale, I apologize. 5 and 7. Let's say this is 3.3, 7.5, and x. And I want to know how long is x. Well, since I already told you these are similar triangles, you should know you can set up a proportion and solve this. So choose any two sides that you know, for instance, that match. So like for instance this 2.2 and that 3.3, those are corresponding sides. You can match those up. Or you could go with, sorry, that was supposed to be in a different color. Let me get rid of that. Or you could go with this 5 and this 7.5. Those are corresponding sides. Either way. So let's use the 5 because it's, you know, a pretty easy number to use. So what we're saying is 5 over 7.5 is equal to, well, what am I trying to figure out? I'm trying to figure out x, and its corresponding side length is 7. So that's 7 over x. Now keep in mind, there are many ways to set these up. This is not the only correct way. You could have said x over 7 equals 3.3 over 2.2. Just one more example of how you could have done it. You could have even done like x over 7.5 equals 7 over 5. Really does not, as long as you're doing it the same. Notice this way was different because I did two sides of the same triangle on each fraction, but I did them in the same order on both sides. So there's more than one right way to set this up. And of course from here, you're just going to cross multiply and divide. Let me get rid of these extra, well, I'm going to attempt to get rid of these extra things here. I'm going to try. Alright, so cross multiplying we get 5x equals 7.5 times 7 is 52.5, I believe. I hope so. We'll find out in a second if this number works out to be the right answer. Yeah, it's 52.5. And then we divide by 5, and we get x equals 10.5. And that is the right answer. Also notice that all of the side lengths over here on this left triangle are 1.5 times the side lengths on the right triangle. Okay, so that's a proportion. Proportions are pretty easy. If you followed me through all of this, you should be good to go. You're also probably sick of listening to these math problems, so maybe you need a little breather, a little water break before you take the test. But you've seen everything you need to see to do well on this test. Feel free to contact me with any questions. Remember, the test is due by midnight Sunday. Okay, good luck.